Hey everyone, in this video we are going to be solving this Leetcode problem 55 jump game. So let's see what the problem says. It says you are given an integer array nums. You are initially positioned at the array's first index and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. So what this says is that we are given an array with some values, okay, and each of these values represents a jump length. That is, it is the maximum jump length which we can jump from this position to another position. Okay, so for this array we are starting at index 0, the value is 2, and from 2, so from 2 we can jump to either 3 or 1. At max we can jump to 1. Okay, if we jump to 1, from 1 we can jump to this one, and from this one we can jump to 4. Okay, and we can return true. If we are jumping from 2 to 3, at most we can jump 2, so obviously we can jump length 1. So if we jump to 3, we can jump directly to 4. And if we jump from 3 to 1, we can jump to 3 to 1. Then from this one to we can jump to this one and to this 4. Okay, so in every case, I am not going to explain further. In every case we can jump from start of the array to the end of the array. Okay, and so we can return true. Okay, now let's see this example. In this example, what we can see is we can jump from 3, we can jump at most length 3, so we can jump to 0. In this case, if we are jumping length 2, we are jumping to 1, and from 1 we are again jumping to this 0. If we jump from 3 length 1, so we are jumping to this 2, and from this 2 we can either jump to 1 or this 0. So in every case in this array we are ending at 0, and from 0 we cannot jump because no length is given at 0. So in this case we are returning false since we cannot jump further. So we can solve this problem in two ways. One of the ways will be to use dp, okay, and another way is going to be by using greedy. Okay, so we're going to be looking at both the solutions in this case. I will be coding only the greedy solution. Okay, so let's now look at the dp approach. I have already taken a screenshot of the problem. Anyways, so let's see for that example. Okay, let's see for the example that was returning false. So in this example, what we can see is we are let's see for this example. Okay, so in this example we are having 3, and from 3 we are jumping to 2. We can jump to 2. Okay, so at first we have 3 index 0 index 3. Okay, and from 3 we can jump either length 1, or length 2, or length 3. Okay, so if we jump length 1, we will be arriving at 2. If we jump length 2, we will be arriving at 1. If we jump length 3, we will be arriving at 0. Okay, and if we jump to 2, we can again jump to maximum 2. Okay, so if we jump 1, we are jumping to 1. If we jump 2, we are jumping to 0. If we and this gets over for 1, we can jump to only 1, that is 0. So in all the cases we are getting 0. Also for this one we can jump to 0. Okay, so for all the cases we are getting back 0. Okay, so the solution would be like dp of 3 equals to 0, dp of 1 equals to 0, and so on. Okay, so this is how we can solve using dp, but it's of O of n to the power n complexity, and it's not very good algorithm to solve this problem. This problem can be solved in O of n complexity. Let's now look at how we can solve this in O of n complexity. Okay, let's erase all of this. And so let's think about some sort of trick, okay, to solve this problem. Let's suppose we are starting from the end of the array. Okay, let's suppose we are starting from the end of the array, and imagine this is our goal. This is the goal we have to reach. Okay, this is the goal we have to reach. Let's see for this example, because this returns true. Okay, let's suppose this is our goal. Okay, and from the start we are currently here at the starting index. Okay, and we have to reach to 4 to our goal. Okay, so what we can do is we can think backwards. Okay, we can think backwards from 4. So let's suppose we are at let's think, can we come from this 4 to this 1? Yes, of course we can come from this 4 to 1. I mean, like, can we jump from 1 to 4? Yes, we can jump from 1 to 4. So can we reduce our goalpost to 1? Yes, we can reduce our goalpost to 1. Okay, let's now think of this one. From this one, can we jump to this one? Yes, we can jump to this one. So can we further reduce our goalpost to this one? Yes, we can reduce our goalpost to this one. Now we have a 3. From these 3 we can either jump to directly to 4, or we can jump to this one. Now in this case, we this jump to 4 is not necessary, since our goalpost is already in this position. Okay, so we can jump from 3 to 1. So this is how the solution is going to be. It's very easy. Just think about the solution. If you do not understand, just think about the solution for a little bit and you will get it. Just think and you will get it. This is very easy. This is very easy problem. Okay, now let's code this up. Okay, so we can have a goal, that is, it will start at the end. Its value is going to be the end of the, sorry for the dog barking. It just barks at night. Sorry for that. So what we can do is, int I equals to 0, I greater than equals to 0. We are looping backwards. Sorry, this will be nums dot length minus 1. We are looping from the back. We are looping from the back of the array, and this will be I minus. And if the value of I plus nums of I is greater than equals to our goal, what we can do is reduce our goalpost to that position at I. Okay, and at last we can return goal equals to 0. So if the goal is equals to 0, we can return true. If the goal is equals to 0, we can return to false. That is, it does not come to the last index of our array. It stops here. If we look at this example, from 0, we cannot reduce our goalpost from 4, since from 0 we cannot jump to 4. So we are returning false. Let's run the code and see if it works. It's accepted. Let's submit. Everything runs and everything goes smoothly. So this is the solution from the problem. So if you like the video, please give it a thumbs up and subscribe to the channel. It would help me with the algorithm. And thank you. Bye. See you.